Hey there everyone, welcome back to Lead Coding. In this video we will be solving the third question of Lead Code Weekly Contest 220. Name of the problem is Jump Game 6. We have already solved jump game problems in the past. You can find the link in the description and you can go and watch the video. Now let's move on to this problem. You are given a zero index integer array nums and an integer k. You are initially standing at the index 0. In one move you can jump at most k steps forward without going outside the boundaries of the array. That is, you can jump from the index I to any index in the range I plus 1 till I plus k. So we should remain within the boundaries. We have to reach the last index, that is n minus 1. Your score is the sum of all the nums of j for each index j you visit. Return the maximum score that you can get. Now we are starting at the beginning and here we have the summation as 1. This is our score because we are visiting the first index or the 0th index. Then we can make a jump to the index 1 or to the index 2. Now looking at both of these numbers, I think jumping to the index 1 is going to give us more benefit because we will only be losing 1 point because the element here is minus 1. So we'll jump to this index. Then from here we will have two options to jump. Obviously we are going to jump to the number 4 because 4 is giving us more benefit. So now the total summation will be 4, and from here we will be jumping to 3. That is the last index. The total summation will be 7. Looking at the second example, we already have 10 as the score. We have three options to jump: minus 5, minus 2 or 4. Obviously we are going to jump to the positive number because we don't want to lose points. So we will have 14, and from 4 we will jump to 3. Next, here we have 1. We can jump to minus 5 or minus 20. We will be jumping to minus 5 because it is the maximum number that we can jump on. Then from minus 5 we will be jumping to 4 because 4 is positive. From 4 we will be jumping to 3 because 3 is positive, and from 3 we will be jumping to minus 3 because it is the least negative in the range of numbers that we can jump. So what we can conclude? So let us say we are standing at a certain index. And we have a range to which we can jump. We can jump from, let us say, this range till this range. And in this range, let us say if all the numbers are negative. So if all the numbers are negative, in this case we can jump to the number which is the greatest among all these negative numbers. That's what we saw in the examples. Now let us say if there are some positive numbers in this range, then we'll have to make the jump to the nearest positive number. Why so? Because we want to include that number in our answer. We want to maximize our answer and we want to include that number. Let us say this is the nearest positive number, so we can jump to this number so that we can get these many points. So why are we eliminating the other possibilities? Let us say if there is another positive number here and that is greater than this, why are we not jumping to this number? The reason is simple, because even if we include this number in our answer, even if we are jumping to this position including this in our answer, we still have the possibility to include this as well, because it will come inside the range. When we are at this position, it will come inside the range of the next jump. So we can always include this in our answer if we are including the number which is previous to this and which is positive. So that is why we can go greedy in this problem. We can jump to the nearest positive number, we can include that into our answer, and from there we can jump to the next positive number, next nearest positive number. We want to include as many positive numbers as we can in our answer. And we already discussed, when all the numbers in this range are negative, then we want to avoid all of them, but we will have to make a jump. So we will be jumping to the negative number, the smallest in magnitude. So the same we are going to do in our code. Let us start writing the code. So this is our starting point. It is 0. Initially our answer will be equal to nums of 0, while s is not equal to n minus 1, where n is the size. Let us run a loop. I is equal to 1. This is for jump taking one step. I smaller than equal to k. I plus plus. So these are the steps that we can jump. If s plus I is within the range, if s plus I is smaller than n, then if nums of s plus I is greater than or equal to 0, if it is positive, then we can make a jump to that position. Or if it is the last position, if it is n minus 1, s plus I is equal to n minus 1, then we can make a jump there. So for that we can include in our answer this nums of I plus s, and we can make this s is equal to I plus s, and we can break out of this. Otherwise, as we discussed, that if all the numbers are negative, then we will have to go to the lowest, the one which is lowest in magnitude, or the greatest negative number. So for that, let us keep an index x which is equal to s plus 1. So if nums of s plus I is greater than nums of x, then x is going to be s plus I, and we will keep a flag. This flag will denote that if we have all the numbers negative. So in this case, if a number is greater than or equal to 0, we will set the flag as 1 before exiting out of the loop. Before breaking out of this, we will set the flag as 1. It means that we found one number which is not negative, and in that case we won't do anything. But if f is still equal to 0, it means that all the numbers were negative. In this case, we know that the greatest negative number is at the position x, so answer plus equal to nums of x, and s will be equal to x. We can return the answer. Let us see if everything is correct. In the line number 12, seven, 17 and 0. Let us try to submit this, and it got accepted. So talking about the space complexity, we are not using any extra space here. It's just constant in terms of space, and the time complexity is big O of n, where n is the size of the array. How is it n? So let us so this s is starting from 0, and on each iteration s is moving to a certain index. In the worst case, we can have all the numbers in the array as positive, and then we will move step by step, one step at a time. So that's why we can see that the time complexity is big O of n. So this is it for the solution. If you like the video, please subscribe to the channel. You can see the solution to the previous problem as well. I have uploaded that, and the solution to the last question and the first question, I will provide them as well. Thank you.